Today, we're going to talk about the law of sines. Okay? It's called the law of sines. So before we do anything, the law of sines deals with opposites. So we always want to find, so up here I'm going to put, we always want to find a pair of opposites. Okay, so I'm going to highlight that because that's really the key to this whole lesson today is find a pair of opposites, okay? So what I have drawn down is a little picture of a triangle. It could be any triangle. It could be triangle ABC, but the trick is this. If you know this angle, call it theta 1, you would have to know its opposite side. Theta 1, opposite side. Theta 2, opposite side. Now you could have a theta 3 and opposite side, but you only need two of them, okay? So the trick is you need to know a pair of opposites. So if I come down to this triangle here, I've got my 40 degrees, and I have my 5. I have a pair of opposites. See that? I've got an angle and its opposite side. I have this 6, which means I could find its opposite angle. Okay, so how does it work? So if you want to find an angle, so to find a missing angle, we're going to use this formula. Write this down. Sine
of
theta 1 over opposite 1 equals sine of theta 2 over opposite 2. Okay, that is the formula, okay? Price might have given it to him. You never know. Okay, so let's highlight that. Highlight that up, okay? Highlight that, okay? That's our formula. It's a really easy formula. It's easier than sine, cosine, tangent. Super easy formula, and it's easy to use too, okay? So if I go down to this triangle, okay, triangle 1, and we can call it anything you want, okay? I don't care. Give me a, Katie, give me a 3-letter word.
Cat.
Cat. Triangle C-A-T, all right? Here's how it works. First, find a pair of opposites. So if I look here, I've got an angle, and I have an opposite side. So I'm going to circle those. So find a pair of opposites. Okay. Once you have a pair of opposites, you can use the law of sines. I'll say it again. Once you find your opposites, an angle and its opposite side. Once you have an angle and its opposite side, you can use the law of sines. Well, how does it work? Well, I've got a 6, and I'm doing opposites, right? So if I've got the 6, I should be able to find its opposite angle, right? So I'm going to set it up. And I always like to put the unknown first. I like to write the unknown first. What I don't know is A. But the formula goes sine of an angle. Sine of an angle over its opposite side. So I'm going to write sine of angle A. Sine of theta, or sine of angle A, over its opposite side, which is 6. Okay? Sine of an angle over its opposite side equals sine of an angle, or sine of 40, over its opposite side, which is the 5. Okay? So, you find your pair of opposites. You can locate possibly another pair of opposites. If I have 6, I can find its opposite angle. So I write it down as sine of theta, in this case, angle A, because theta means A, means angle, over its opposite side, which is 6. Sine of theta. Theta means angle, so sine of 40 over its opposite side, 5. Now all I have to do is solve for A. But before I do anything, I know that if I want to find an angle, I know for sure the last step I'm going to use the sine inverse. Remember, if you have to find the angle, we use the inverse sine, right? So to solve for A, I'm just going to first multiply up the 6 because I want to solve for A. So let's just multiply by 6. So I'm going to rewrite this as sine of A is equal to 6 times the sine of 40 over 5. Now this is a number. This is a number in my calculator, okay? Now I want to find out what that number is, okay? So I'm just going to use my calculator. I'm going to type that in just like that. I'm going to go, okay, I'm going to go 6 times the sine of 40 divided by 5, and I get a decimal. Well, that can't be angle A. That's a sine of A. Does that make sense? So what I have is really sine of A is equal to 0.7713, blah, blah, blah. But if I want to find my angle, to find an angle, I have to do the inverse. So I'm going to go sine inverse of 0.7713, blah, 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 blah. So I'm going to use my calculator. I'm going to go sine inverse. And I like my answer button. For two reasons I like my answer button. So if you're not sure where the answer button is, it's down by the negative. I like the answer button because I don't have to retype that. Plus it's more accurate because I get to use all of those decimals. So enter 50.5. Okay, now that seems like an angle, doesn't it? Okay, so angle A is 50.5 degrees. Okay, now from here I can find angle T pretty easily, can't I? Yeah, I don't need trigonometry, just subtract from 180, right? So I can go, okay, angle T, I can set up angle T is equal to, let's see, 180 minus my 40 plus my 50.5, right? 180 minus parentheses 40 plus 50.5, and I get an answer of about 89.5, okay? Okay, how am I doing? So far so good? Well, here's my dilemma. If I want to find this third side, I can't use Pythagorean's theorem.
Wait, can you?
Yeah. Okay, so if I want to find this third side, Pythagorean's theorem will not work. Okay, which way? Okay, so to find this third side, I'm going to have another technique. Again, I'm going to use the law of sines. So I'm going to come back to this. I'm going to show you an example 2, how you find the side using the law of sines, and then we'll come back to this and finish the triangle up, okay? So I have everything else except for little t, side little t. We're going to come back and do little t once we figure out how to find the sides, okay? So let's look at example 2. So if you want to find a side, to find a side, it's the same formula, except we put the side on top. Exact same formula. We're going to go opposite 1 over the sine of theta 1 equals opposite 2 over the sine of theta 2. Okay, and I'm going to highlight that. So it's the exact same formula. The difference is we just put the sides on top. Okay, it makes it easier to solve. Okay, so let's take a look at example 2. Well, I need a pair of opposites. Before I do that, I need a name. Give me a. We'll go with Ben. How about we go B, E, N? We'll go with a Ben triangle.
That's the baby one.
Bob won't work
Why?
because it's two B's.
Oh, I guess.
But Lauren, let's use Ben.
Okay. We'll
Okay.
use Ben.
Ben will work. Okay. Now, do you see a pair of opposites? You don't. I don't. 82. There's no opposite side. 70. There's no opposite side. 13. There's no opposite angle. But we can probably get angle E. You think?
Yes.
Guys agree? So let's get angle E first. So angle E, 180 minus my 82 plus my 70.
28.
Is it 28, Ben?
Yes.
Okay, 28.
Is it 28 Ben?
Okay. Now, since we got that angle,
Angle 80.
do we have a pair of opposites? Yeah. I've got a pair of opposites. So look for your pair of opposites. Angle, opposite side. So look for your pair of opposites. You guys see it? Now, in this case, we have two angles. We could find side B, or we could find side N. It doesn't matter, because all we need is a pair of opposites. It does not matter. Ben, do you want to find little b, side B, or do you want to find little n? It does not matter.
Little B.
Okay, little b it is. So if we find little b, we'll use the 82-degree angle. Opposites. It's all about opposites. So let's use our formula, okay? So, opposite 1. Let's use little b. I like to write down the unknown first. Let's put little b on top. So side, I'm going to go little b over the sine of its opposite angle. So little b over the sine of 82 is equal to, well, let's use our opposites, okay? Opposite 2, which would be 13 over the sine of 28. Right? So it's set up. We've got the side over the sine of its opposite angle. I have the side over the sine of its opposite angle, right? So now if I want to solve, I'm just going to multiply up the sine of 82 and multiply that up there, okay? And I'll rewrite that as a b is equal to 13 times the sine of 82 divided by the sine of 28, okay? And I'm just going to use my calculator. I do not need an inverse because I know the angle, right? So 13 sine 82 divided by sine of 28, and I get an answer of about 27.4, okay? So little b is 27.4, okay? Okay, now if we have to solve the triangle, we got one more thing to find. Ben chose little b. Let's find little n.
Let's do it.
Okay, we got opposites, don't we? We got opposites. So we do the same thing. We're going to say, okay, little n over its opposite angle, right? Little n over the sine.
Can you move it over?
Yeah, little n over the sine of 70 equals, we need our opposites. 13 over the sine of 28, okay? And I'll multiply up the sine of 70, right? Multiply this. Okay, so little n in my calculator, little n is going to equal 13 times my sine of 70 over my sine of 28. And I'm just going to use my calculator. I'm going to go 13 times the sine of 70, close my parentheses, divided by sine of 28. I get about 26. Little n is 26. Okay. Now, we can go back up and finish problem number 1. Okay. So if we go back up to finish problem number 1, am I going too fast? Okay. So if I go back up to number 1, if I want to find little t, right, I've got a pair of opposites, right? So we're going to go little t over its opposite, right? Little t over sine of 89.5 equals 6 over the sine of 50.5, right? So it all has to do with opposites. If I want to solve for t, I'm going to take and multiply this up here. And so I'm going to write, I'm running out of room, but t is equal to 6 times the sine of 89.5 divided by sine of 50.5. Just use my calculator. It is, but it's not hard. Divided by sine of 50.5, and I get an answer of about, no, that's not right. Try that again. 6 sine 89.5 divided by sine 50.5. How about an answer about 7.77? Okay, now. Yeah, Nikolai.
I was wondering if after this I could have that paper.
Sure.
That was a very polite.
Yeah, Cooper?
Does the next question get harder?
No, it's easier.
I use the bathroom?
No, because it's a totally different formula. Why don't you wait? Okay, ready to turn the page? Okay, now, area. Totally different question. Area. Totally different question.
That is a way different question.
So what we've learned is that to find area, it's base times height divided by 2, right? The only problem is in this triangle, you don't know the height. You could draw in the height, but it won't do you any good because if you draw in the height, you don't know what either sides of these are, right? So you need another formula, okay? Now again, one more time. It's not a right triangle. There's no hypotenuse, okay? In fact, if you have an angle, there's two sides next to it, so you can call that maybe adjacent 1 and maybe adjacent 2. It doesn't really matter, but they're both adjacent sides because they're both next to it, right? And we'd have an opposite side, right? So the area of a triangle is as easy as this. Area is equal to 1/2 times the adjacent side, we'll say adjacent 1, times the other adjacent 2 times the sine of theta. That is the formula. It's super duper easy. I'm going to highlight that. That's my area of a triangle formula, okay? Now, let's take a look at our last example, Cooper, and then you're out of here, okay? Now, I've got two sides, right? Which angle should I use? I've got two sides. I need to use the 58. I have to use 58 because that would make these two the adjacent sides. Does that make sense? So if this is adjacent, and this is adjacent, my area is as easy as this. It's 1/2, because that's the formula, times adjacent 1, 5, times adjacent 2, 6, times the sine of 58 degrees. That's it. Super easy, isn't it?
So easy.
So I'm just going to use my calculator. I'm going to go 0.5 for 1/2, right? Times 5 times 6 times the sine of 58. About 12.72 centimeters squared.
Wow.
Easy day.
Centimeter square.
Have you never learned this? Have you